All right, let's get started. Today, we're going to do something a bit different. Think of it like a forensic investigation. Not for a crime, but for a story. And not just any story, but maybe the most powerful scientific story of the last couple of centuries. The theory of evolution. We all think we know the story, right? But where did the story itself actually come from? That's what we're digging into.
So if you ask most people, the story starts right here. 1859, Charles Darwin publishes On the Origin of Species. And it's usually painted as this great moment for British science, right? But here's the question we're investigating. Was Darwin really the guy who came up with the idea, or was he just the one who figured out a mechanism for an idea that was already out there? The answer? Well, it might just surprise you. To get to the bottom of this, we've got to go way, way back. I'm talking much further back than Victorian England. Our first stop? Ancient Greece, over 2,500 years ago. This is where the very first seeds of a naturalistic origin story were being planted.
Okay, check out this timeline. This is what's so wild. Long before Darwin was even a thought, people were already kicking these ideas around. I mean, all the way back in 610 BCE, you've got this Greek thinker, Anaximander, suggesting humans came from other animals. A century later, another guy, Empedocles, is talking about a bizarre kind of survival of the fittest. And get this, even earlier, like 1500 BCE, you have Vedic texts in India talking about these huge, vast cycles of time for the universe. They were really setting the stage for a completely different kind of origin story.
Let's zoom in on Anaximander for a second, because his logic is, well, it's kind of mind-blowing for the time. He looks at human babies and thinks, hey, these things are totally helpless. There's no way the first humans could have survived. So he reasons we must have come from other animals. He even pictured us being nurtured inside these fish-like creatures until we were old enough to take care of ourselves. And what's key here is that it's a totally natural explanation. No gods needed, just heat, water, and a whole lot of time.
All right, now our investigation is about to take a really interesting turn. We're jumping from Greece all the way to ancient India. And what we find there is, well, it's a religious sequence that lines up with the modern evolutionary timeline so closely it's almost spooky. It's called the Dashavatara, the 10 avatars of the god Vishnu. Just look at this progression here. It is so deliberate. It kicks off with Matsya, the fish. Life starts in the water. Makes sense. Then you get Kurma, the tortoise, which is an amphibian, making that move from sea to land. Next up is Varaha, the boar, a full-on land mammal. Then it gets even more specific. Narasimha, the half-man, half-lion, kind of representing that jump to early human-like forms. And finally, Vamana, the dwarf human. This isn't just a random list of myths, you guys. It's a clear, step-by-step biological progression, moving upward. And you might be thinking, okay, are we just reading this into it with our modern eyes? But no, that's the kicker. This is not some New Age reinterpretation. Back in the 19th century, right when Darwin's ideas were exploding, you had Hindu scholars like Swami Vivekananda basically saying, yeah, we've had a religion of evolution in our scriptures for thousands of years. So the point is, this whole idea of life progressing in stages was already deeply woven into ancient thinking.
So the big question is, how did these ancient, you could say pagan ideas, especially from India, travel all the way to Britain and create the perfect intellectual storm for a scientific revolution? Well, this is where our investigation uncovers, which you could call the Great Swap, a huge trade-off in worldviews.
This slide just lays it out so perfectly. On one side, you have the established Western model, rooted in Hebrew texts, a young Earth, maybe 6,000 years old, with life created in fixed, distinct kinds. Then, look at the other side. This new academic model that pops up in the 1800s, it looks uncannily like the Hindu model. We're talking vast billion-year spans of time, slow and steady change, and life forms that are fluid and can transition into one another. The inspiration literally shifts from Hebrew texts to Sanskrit texts. This wasn't a discovery that came from digging up rocks, it was an imported philosophy.
And we can actually trace the paper trail. These Orientalist scholars were the ones who built the bridge. You have Sir William Jones, who basically applied an evolutionary idea to language before Darwin did it for biology. He proved that Sanskrit, Greek, and Latin all came from a common ancestor. But even more critical was Horace Hayman Wilson. He translated the Vishnu Purana, and he did it right there in London. He's the one who made ideas like deep time, these billion-year kalpas, and that whole Dashavatara sequence popular in the exact academic circles where Darwin and his mentor Charles Lyell were hanging out.
Okay, so it really looks like the philosophical groundwork was imported from the East. But what about the science? What about the hard evidence? This new model absolutely requires deep time. We're talking billions of years. So, let's do what any good investigator would do and put that core assumption to the test with some observable data.
First up, let's talk about what the source material calls the comet problem. Okay, so think of comets as these big, dirty snowballs, right? Every time they swing around the sun, they burn off a little bit of themselves. They're literally melting away. And based on how fast they decay, they should all be completely gone in less than 100,000 years. So here's the million-dollar question. If our solar system is supposedly 4.5 billion years old, why do we still have any comets left at all? It's a pretty big puzzle.
And that brings us to a really important idea for this investigation, the rescue mechanism. Here's how it works. When you have evidence that directly contradicts your main theory, instead of throwing the theory out, you invent a new, unobserved idea just to save it. In the case of the comets, that rescue mechanism is something called the Oort cloud. It's this theoretical, never-seen-before reservoir of new comets way out at the edge of the solar system, just waiting to be pulled in. It's an idea that exists purely to protect that deep time story.
Okay, now let's jump over to genetics. This is fascinating. You've got two different clocks. On the left is the standard evolutionary clock. It starts with the assumption that humans and chimps share a common ancestor from millions of years ago. When you calibrate the clock with that assumption, it tells you that our common maternal ancestor, mitochondrial Eve, lived about 200,000 years ago. But then look at the clock on the right. This one isn't based on an assumption. It's based on the observed mutation rate that we can measure in families, right here, right now. And that clock points to a starting point of only about 6,500 years ago. That is a massive difference. So to close that gap, you need another rescue mechanism, the assumption that mutations must have happened way slower in the past. It's an idea to make the numbers fit. All right, now our investigation is drilling down to the very core of the theory itself, the engine of evolution, mutation. The whole story depends on the idea that random mutations can build new, useful, complex information over millions of years. But what does the data we can actually observe today show us?
Well, the data points to this principle called genetic entropy. You can almost think of it as biology's version of the second law of thermodynamics. You know, the one that says everything tends toward decay and disorder? It's the same idea. Random changes to a super complex system, like a genetic code, don't build it up, they break it down. At their core, mutations are just copying errors, and over time they lead to a net loss of information.
This is such a great way to think about it. A genome is like a car that's slowly rusting. It's not going to fail because of one giant explosion. It fails because of thousands and thousands of tiny little rust spots. These are the mutations that just keep accumulating. And the key is, natural selection is blind to most of them because they're so small. So each new generation gets a copy of the code that's just a little bit rustier than the last one, leading to an eventual, inevitable system breakdown. And this really puts the two models in a head-to-head collision. Darwinian evolution predicts a steady, upward climb from simple to complex. But what we actually observe with genetic entropy is a downward slide, a decay from complex to simpler, or broken. It totally flips the script on time, too. In the Darwinian story, time is the hero, the magic ingredient that makes anything possible. But in the entropy model, time is the enemy. It's the thing that guarantees everything will eventually fall apart. So, if the evolutionary story, which seems to have its roots in Hindu philosophy, needs all these rescue mechanisms just to stay afloat against the observable data, what framework does fit the data? Well, our source material wraps up by proposing an alternative, one it claims fits the evidence without needing any rescues at all. Okay, this table really brings the whole investigation to a head, according to our source material. Let's just walk through it. We've talked about genetic decay, which directly contradicts the upward progress evolution needs. We've seen how the fast mDNA clock and the short comet lifespans seem to need rescues to fit the deep time model. The source also adds a couple more data points, like finding soft tissue and even blood cells in dinosaur fossils, which is really hard to explain if they're 65 million years old. And finally, genetic patterns that trace most of us back to just 3 main maternal lines. So when you strip away the rescue mechanisms, the source concludes that the one framework that seems to match all of these observable data points is a model of recent special creation, followed by the genetic decay we see all around us today.
And that brings our entire explainer to a close, leaving us with one last big question. When a story, even a really powerful, widely accepted origin story, seems to need invisible comet clouds and theoretical breaks on our genetic clocks just to keep it from clashing with the observable evidence, what do we change? Do we change the evidence, or do we change the story? That's a question we're thinking about.